Good afternoon, ladies and gentlemen. My name is Holger Ritter. I'm managing partner of Drynet. I will talk a little bit more from a market perspective today, not so much from a technology perspective. Also, our company is... okay. Also, we have a long-term background. Our company is now going into its 20th anniversary. And since 2004, when I supported connection by Boeing, we brought the first Wi-Fi in the sky on airplanes based on VSATs at that time. Since that, we are doing constantly satellite projects, mainly in the maritime world. Wonder why we are located in Kiel, close to the east end of the Kiel Canal, which is the most frequented waterway in the world. So I always, when I'm in South Germany, I try to make a little bit promotion for that. That also BMW, for example, is depending on this infrastructure. And so this is the agenda I want to walk you through this afternoon. Our small company, as I said, is based in Kiel. We are pretty much focused on maritime communications. That means both satellite and cellular. So that means we are connecting ships to the internet. And we do this now since 17, 18 years. One example for you that you all might know, for example, we are working with TUI Cruises now since 2009. We have a company, TUI Cruises, for all their Mein Schiff cruise ships, and bringing satellite communications on such cruise ships means always connecting a small city. Yeah, we are talking of 4,000 people on board, but we are now talking also about IoT and 10,000 of sensors that are on such a ship. All right, I think we have seen a similar chart already, so I go quickly over that. The general NTN architecture, I think this has become clear this afternoon already, that we are talking of different components in the non-terrestrial network. We are talking of the mobiles, we are talking of the ground station, we are talking of the satellite operation center. This is completely, today, this is completely different from what you know in cellular. And this is a paradigm shift. That will change in the future. So the new space operators I'm coming to in a moment, they are already putting up their ground infrastructure based on the principles of 3GPP, 5G infrastructure, so that it will be a harmonized infrastructure in the future, satellite and cellular. I think we already had a similar chart, but this will show you the different orbits we are operating in satellite. GEO, to make it very clear, 36,000 kilometers away. And if we talk about latency on a ship like Mein Schiff 1 or Mein Schiff 2 on a cruise ship, we are talking of a latency that is at least 544 was mentioned shortly ago. This would be very optimistic because you have a lot of processing in between. So 700 to 800 milliseconds, is that what really comes down from a geostationary or geosynchronous satellite? And this is, if you look at the end user experience on board such a ship, is not very good. Yeah? So even if you have a lot of bandwidth, you need to buffer it, you can work with it, okay, but that will change. MEO satellites, they are usually in an area of 8,000 kilometers above our surface. They are also moving, whereas the geosatellites, they stay, from our perspective, on the ground at a certain point in the sky. MEO satellites are moving, and we see there, for example, with SES 03B, we see latencies of about 100 to 150 milliseconds. So already a great improvement. With the LEO satellites that will operate, or that are operating in an orbit of 500 to 1,000 kilometers or 1,200 kilometers, the latency will again go down, depending on a lot of factors. But for example, on Starling, we are measuring now since September, October last year, latencies below 50 milliseconds. This is the old world. In the old world of satellite communications, we see the established incumbents like Inmarsat, Iridium, Viasat, Intelsat, SES, etc. most of them, with the exception here of maybe Orbcom and Iridium, are operating geostationary. Or Inmarsat is now launching something special, HEO. This is a polar orbit in order to provide also coverage for the Arctic and Antarctic regions. But these are mainly traditional operators working in C-band, Ku-band, Ka-band on a geostationary or geosynchronous orbit. That changes now with what we all talked about today already, new space. New space is an ecosystem of startups, but also of new investments of the traditional incumbents. And I will come to that in a moment, what is typical for new space, because there's a paradigm shift in the whole industry that will also lead to a disruption in economics. Just to give you an idea, in this world here, when we talk about L-band Inmarsat, we talk about that 1 gigabyte of data for the end user costs roughly $1,000. In the typical VSAT scenario, we talk about 1 megabit per second costs roughly $700 to $800. But here, in this world, we will see a factor of 10 to 20 for the end user, maybe sometimes 100 for the end user, that bandwidth gets cheaper and gets more affordable. So that will change a lot of business models of the traditional companies, but also the new companies. So innovation is, as we have just heard before my presentation, innovation is a great thing, or a great sign for the new space. And I've just here 4 things, they are not exclusive, so they're just examples here. Skylo, for example. Skylo is a company that develops software with which you can make chipsets of cellular devices satellite capable, based on, of course, 3GPP, NTN 17, 18 standards. That means Skylo will be a software that helps us all to use in the future our small devices, our smartphones, but also other modems, etc., which we use currently here for space connectivity. Totum is a Californian company. They developed a chipset which can be used for satellite inside of rooms. Sounds crazy. And I really want to test it. I did not so far, but it's an interesting innovation. The efficiency or the sensibility goes down to minus 143 dBs. That's what they say, that's what they claim. Spire is a company that has already proved that they can provide a LEO technology completely software-defined. Spire launched completely software-defined satellites. They have now about 140 satellites in the sky. They are providing, for example, a satellite AIS. AIS is the positioning system for ships worldwide. Usually it comes from radio frequency FM-based stations along the coastlines and along the rivers. But on the high ocean, there is no such. So you need satellite on the high ocean. Also, for example, big advantage, recently China blocked AIS signals, terrestrial AIS signals, of all foreign ships that were in China. Only ships with satellite AIS could be tracked via AIS by companies like Hapag-Lloyd or Evergreen or all those container shipping companies. So that means also, we have heard that a little bit ago, that new space makes us all more independent from a positive perspective. Yeah? I'm not talking about landing rights or licenses, etc., but in general, there's a potential that makes us all more independent from national cellular infrastructure. Starling, of course, is also a great innovation. This antenna you see here was the first terrestrial Starlink antenna at a price they sold it of 500 euros, highly subsidized, of course. Phase array antenna We have it since September on our rooftop, on our office. Works great. Sees 8 to 10 satellites at a time, and it has a lot of new innovations. For example, I don't know, has anybody of you installed a Starling antenna? No? Two? Okay, all right. In order to, how was your experience? Did you use your smartphone to move around it in order to make it look to the satellites?
I did everything in 20 minutes, and that's why I bought a satellite.
Exactly, yeah. So you can use the camera of your smartphone, put it on the dish to look up where are the Starling satellites. And the system will learn it and will adjust the antenna to it. For the end user, so much easier, so much simpler than everything what has been before. Use cases for the nice new world. Anything you can think of, any industry, for IoT, for broadband, for the end user, where there is no cellular coverage today. And we heard this already today. Only 40% of the land masses are today covered with cellular. And also at sea, 70% is covered by sea. Don't forget about the 3 million seafarers that are traveling at sea. They want to connect all to their families at home. They want to use WhatsApp when they are 6 months in an engagement at sea on a ship. They need internet access. And also a lot of tourists on the cruise ships. This is a million passenger industry. And also the leisure market on maritime. They need satellite access. Of course, all the other things, mainly where there is no cellular network. And in the future, the bright new future, where we talk about convergence between satellite, 5G, and then 6G, hopefully we get all devices that support us to roam seamlessly from the high-speed 5G or 6G network, let's say here in a city. When you go outside to the countryside where there is no network, you can roam onto satellite. Okay, let's go a little bit more specific. What are the characteristics of new space? First is new satellite design. What you see here is a CubeSat. And you see the size of the hands. This is pretty small. This is very small. And in comparison to what has been up in the sky on geosynchronous orbit, a satellite from Inmarsat, for example, the 4th or 5th generation satellite that is on the geostationary orbit, that would just fit in this room. Yeah? And here we are talking of thousands of these small devices. Also, the business model changes. The big satellites have been made for 20 years, for an operation time of 20 years. They are a huge invest, billions of dollars. But thousands of these small satellites, which are made for 3 to 5 years, maybe sometimes 7 years, they have to be replaced constantly. So there's a shift between in the satellite industry from CapEx to OpEx. The new constellations will have a much higher OpEx, operational cost, than the old. We have to notice that it is not sufficient when Elon Musk launches now 4,000 or 5,000 satellites. And in the next years, another 10,000, another 20,000. He needs to constantly replace failed satellites, satellites that go out of order, constantly in his fleet. Otherwise, he will not keep his license. All right, but let's say, anyway, those small satellites have some nice new features, for example, software-defined and custom-built. They have become pretty cheap, so you can build today your own small CubeSat if you have a specific application and bring it up. Shorter time to market. Also goes with software-defined. If you have an idea, talk to Spire today. They can help you to bring your sensor, your camera, your computing device up in the sky for little money with their satellites, because they are software-defined. There's also new scale. We are talking of mega constellations. We are talking of launch vehicles, which bring up hundreds of satellites at the same time in the sky. We are talking also of vertical integration. We saw that with SpaceX and Starling. They try to put the whole value chain in their business. That means from the launch vehicle sometimes even from the development of the satellite over the launch vehicle up to the service to the end user. And what we also see on this scale is, okay, for what are these satellites? If we talk about IoT and such things, there must be something also on the terrestrial backend. So a lot of these companies, they cooperate with what we call hyperscalers. They cooperate with Azure, they cooperate with Amazon Web Services, etc. And Azure, for example, Microsoft Azure has already a lot of APIs that help you to connect into Azure and use new satellite services. So there's also an interesting cooperation that was not like this in the past. In the past, satellite business was more or less for its own. They provided interfaces, of course, but it was not even interoperability sometimes. Now this changes. It's going into a connected world. Just an example why it's become so much more economic to bring something in the sky. At the times of space shuttle, we talked about 55K per pound that we needed to bring up in the orbit. $55,000 to bring up 1 pound of something with the space shuttle up in the orbit. Now, when we talk about SpaceX or Falcon rockets, for example, we talk about less than $1,000. Yeah, over 50 times less cost to bring something in the orbit. All right, and what is also a clear trending characteristic, I come to that in a moment, a little bit more in detail, is the cellular SAT convergence. That means on the technical side, of course, we see all the new standards, 3GPP, 17, 18, 6G, further on. But what does it mean on the commercial level? That means that there will be roaming agreements between cellular operators and satellite providers. We see that already with recently launched AST satellite that are launching 5G base stations up on LEO orbit, and they have a global cooperation, strategic cooperation with Vodafone. So we see that is already happening, those cooperations on the commercial side between the cellular operators and the satellite operators. And also telco partnerships directly into that market. This is typical if we go further. For example, Vodafone UK formed a local partnership with Starling in order to provide coverage to those areas in the United Kingdom where Vodafone has no good coverage. But the end user can purchase from Vodafone everything out of one hand. So there will be a team play between existing cellular companies and telcos, and the question is, who orchestrates the whole thing? So today I see a problem, I personally, because everybody wants to be an orchestrator. Talk to Deutsche Telekom, they will be an orchestrator. Talk to Inmarsat, satellite coming. They will also launch LEOs 2026, they say. Oh, we want to be an orchestrator. Then Inmarsat had been bought by Viasat half a year ago. Viasat said, oh yeah, orchestrator, great strategy. So not everybody can be an orchestrator, but there will be for sure a dozen major players that really can fulfill this promise. And one thing, consolidation of traditional incumbents. I mentioned that Viasat bought Inmarsat, I think 6 months ago or so. This is what we see as a reaction to the lot of startups and a lot of new space developments. We also see a huge consolidation in the existing market. Yeah, and that also, because of the huge invest, sometimes more and more governments invest. For example, Telesat putting up a LEO. Telesat is a traditional VSAT operator. So now they had the idea, okay, we go into the LEO space too, and they will really put up powerful LEO satellites in the next 3 to 5 years, called Lightspeed. They are funded with $4.5 billion by the Canadian government. OneWeb, meanwhile, is funded by the UK government and by Eutelsat and by Bharti, which is an Indian telco. So these huge investments, that's also typical to see here, they are often subsidized by governments and by huge telcos. Okay, now one slide about the, what we call mega constellations. Mega constellations means there are hundreds or thousands of new LEO satellites in the orbit, and the one who is the fastest, the one who is absolutely the first mover here is Starling. They have meanwhile 3,000 satellites, I think, in the sky, or 4,000, something around that. 2 weeks ago, that was mentioned, they announced the Starlink system for vessels globally. It's just one size that fits all with Starlink, and it's direct to the end user. So it's a closed shop, it's a black box. But I mean, it's something that is absolutely disruptive for all the market competitors. For all constellations, you can see they all aim for global coverage, which is strategically important. European deployments currently, we see satellites that maybe are available for 20 minutes or for maybe 1 hour a day, because there is no global constellation in place. Maybe in the future, but Europe has to speed up really to catch up with those mainly US-based initiatives. OneWeb, of course, is a European initiative. After they went through Chapter 11, UK government, Bharti from India, and Eutelsat have a major stake. Eutelsat has meanwhile, I think, 25 or 25 point something % into OneWeb. But OneWeb is at least 1 year behind Starlink. With OneWeb, if you want to test it now on your house, you have no chance here in Munich. You have to go 50 degrees north or higher north. Then you can test OneWeb, because there's just no global coverage. Mobile users, OneWeb, probably earliest mobile users on OneWeb, middle of next year. That's when they try to provide services, for example, to ships, etc. Our OneWeb has good cooperations with antenna manufacturers, phase array manufacturers on the lower side, on the lower bandwidth, for example, with a company called Satisfy for IoT, on the higher end with companies like Phaso or Calneda, which provide broadband phase array antennas. Amazon will start at the end of the year with their first antennas, or with their first rocket and their first satellite. So they are, I say, 2 years behind Starlink. And AST has just launched their first satellite together with Vodafone for bringing up a 5G base station in the sky. Telesat Lightspeed, still no launch. And I guess we will see them in 2024. We have seen similar slides in already, so that's why I speed up a little bit. Today we are here still where we have LTE and satellite networks distinct. Interoperation, we are moving currently in a world where we have 5G roaming and backends on satellite which are compatible with the 5G backends of our telcos. But where we are really aiming for is the global network where we have integrated network 6G on satellite, non-terrestrial, and also basically on cellular. This promise, I guess, will be there in 2027, 2028 on first pilots, and maybe 2030 in a broader deployment. This is an example of convergence. I have 2 examples, then I'm done. Convergence example, Skylo. Skylo, as I said, they provide a software for chipsets to upgrade these chipsets to make them satellite and cellular capable. If you provide, and this is based on an eSIM today, the hybrid connectivity based on an eSIM. If you install that, for example, on a truck to transport IoT sensor data to a central control center, as long as the truck is in reach of the terrestrial network, it connects just to the cellular network to which it is assigned. But as soon as he roams out of that network, would connect to satellite. And the satellite backend is the same infrastructure with the eNodeB, for example, as the mobile network operators. So it's easy to integrate here already. Another example, I mentioned it already, is AST. AST brings up 5G base stations in LEO orbits, cooperates with Vodafone, but is not a cube or a nanosat provider. The satellites of AST, they are pretty big when they are unfolded. What you see here, this is the team of AST with their first satellite called Blue Walker or Blue Walker 3. And this has been launched, I think, if I'm not wrong, end of June this year. This is the first of 200, no?
Not yet, they shipped it currently.
Oh, they shipped it, it's not, the rocket not started yet, okay. Yeah. But they plan 240 of these, so it's a huge investment.
Which orbit is it?
LEO
Also
orbit.
LEO?
This is also LEO orbit, yeah. So LEO orbit does not mean necessarily small satellite, CubeSat or NanoSat. It can also be a big satellite. Also Telesat will put up in the low Earth orbit huge large satellites, and they with laser interlinks like data centers in the sky. Yeah, that's it. My conclusion is there's currently something like a very early market, maybe even a gold rush for some people to raise investments in that. And I don't say that everything that is in the market from the traditional incumbents is bad. Yeah? Geosynchronous and geostationary satellites, they will stay and they will have a meaning for a lot of applications, which is very important. They will not die because there will be some LEOs. But there is a change and there are new application opportunities. I have tested last week the terminal from HiSky, phase array antenna, size of half of a laptop. That was so easy to deploy and install and connected to Avanti Ka-band satellite on a geostationary orbit. But HiSky would consider themselves as new space. Every farmer could install it easily on his track or on his tracker. It's really simple to install. And that's another thing. The appliances get very simple for the end user. And there are already hybrid systems that can be installed today, of course. But what we see in the future is more promising regarding convergence. But I think it's about 5 to 8 years, that journey that we have to walk. Okay, that's it. Hope I stayed within the time. Thank you very much.